Hello, let's continue our Sudoku adventure with X's and Arrows by Palfly Kampling. So this continues our Escape the Grid theme week, where every puzzle this week we're going to have a normal Sudoku grid, but some of the clues are going to go outside the grid, and we have to fill out numbers outside the grid, which are affected by our clues and our clues themselves. So how does this work in this puzzle? Well, we do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Now outside the grid can be any integer. These are going to get filled with some integer, and it does not have to be it doesn't have to be 1 to 6, but they do have to follow the rules of the rest of the constraints. Now, if you need to type a digit, like type a number like, I don't know, 15, you can do that by penciling 1 5. If you have to do like 21, you can't pencil it. There's just no way to do it. So just do your best. Like pick something that's going to work for you, even if it means like color it if you have to add 10 or something like that. I don't know. I'm just going to do my best. I don't know what numbers are going to appear, so maybe it'll be nice to us. All right, so we do have arrows in the grid. So digits on an arrow sum to the value in the circle. So if this was 6 and 6, this could add to 12. And again, I'm just writing 12 by penciling 1, 2 in there. You do not need these filled with any particular digit in order for solution check to work, thankfully. All right. In addition to that, if we did 6, 6, and this was 12, then this 12 is also an X sum. So what we do is we look at the digit that's right next to the clue. Say this was a 4. Then that would mean that these 4 digits sum to 12. I'm not going to do an example of that, but if you summed these 4 together, that would be 12. If this was a 5, you'd sum these 5, it would be 12. If this was a 3, you'd sum these 3, it would be 12. And it's in the direction of the clue. So if this was 12, then maybe this would be 3, and these 3 would sum to 12. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, clearly we have to think about these arrows a little bit, but we also think about how they affect X sums. This just calls my attention here, because this is a pretty big sum, right? The absolute minimum in a void would be 1, 2, 3, 4 here and a 1 here. So this adds to at least 11. So this is, why don't I do that color strategy? I'll make this green to signify that we're adding 10 to it. And so this is at least 10. I mean, it's at least 11, right? So how big can it get, I guess? If this was 3, 4, 5, 6, then that adds to 18. And then 19. Sorry, the biggest this could be is 6. So this could actually be bigger than this can be really big by the arrow. But it is at least 10. Now, okay, this is interesting because these are the same digit as each other. So this is definitely 1 through 6, but we can actually eliminate further because some X sums aren't possible. So the 1 is possible, but only if you put a 1 here, because you can only use one cell and then the 1's filled in it. So that actually works, but it doesn't work in this case because 1 would get duplicated. So we can eliminate 1. Now 2 has the problem that 1 always adds to 1, but you can't add to 2 in 2 cells that can't be the same. 1 plus 2 is 3. So 2 is not possible. And then 4 also isn't possible because in order to get to 4, we can't use the 1 because it would only use one cell. We can't use the 2 because we have to do 2 plus 2, and the 3 is minimum 6. So this is a 4, sorry, not 4. This is a 3, 5, 6 X sum. And so how big can this get? Well, it can't be 4 because 4 is up to 10, and it can't be a 1. So this is 2 or 3. All right. Now this 2 or 3 is also the value of we're either using 2 or 3 to sum to this guy, which is at least 11, just naively. We can't get to 11 in 2, so this is definitely a 3. Meaning this can't be a 3, so this is 5 or 6 and 3, but you can't do 5 and 3, so these are 6s. Oh, perfect. So in order to get to 6, this is a 1, 2 pair, and now this is 4, 5. And so we know that these add to, 3 plus 9 is 12, so this is at least 13. Let me think about this. How big can this get? 11 plus 3 is 14. Oh, so this is 13 or 14. Remember the green means I'm adding 10. So 13 or 14 with Yeah, because 13 was the minimum. Sorry. I was trying to think, why did I get 13 or 14? So the minimum would be a 1 here. We know this already adds to 12. And 12 plus 1 is 13. The maximum is putting a 5 here, which makes this add to 14. So that means that this is a 4 or a 5, which affects this x sum here. And this is 1 or 2 to get to 13 or 14. Okay. Now this leads directly into this x sum here. Now, how big can this get? Well, this could be a 5 and a 6 adding to 11. So this can't be a 5 because 5 cells add to a minimum of 15. 1, 2, 3, 4, 5 is 15. So this is a 4. That means that this adds to 13, which means this is a 1. That's a 2 and a 1. Perfect. Now that this is a 4, so actually, let's think about this column. It's 1, 2, 5. I don't think 1 and 2. So 4 adds to at least 10. So this is green because it's at least 10. Which means we can't use 1 or 2 because there's no 8 or 9. So this is a 5. And something interesting about x sums. You can't add to 11 in 4 at least. 11 and 4 is not possible because these 4 cells would include a 4. But the only way to do 11 and 4 is 1, 2, 3, 5. So it kind of contradicts itself. So this actually has to add to 10 then. This is a 2, 3 pair. Because we can't get bigger than 11. This maxes out at 6. So it does add to 10, meaning this is also 5. So that's 4 and 5. This is flowing really nicely. This is a 3, 6 pair. Okay, if this was a 6, this would add to 21. Okay, let me fill a 0 here so that I know it's 10. All right. If this was a 6, it would use the whole column. That's 21. Can this really add to 21? With a 3 here, it seems unlikely. The biggest this could be, actually the 5 is used. But I'm going to be honest. Even in a void, the biggest is 15 plus 3, which is 18. So yeah, there's no way. So this is 3, this is 6. Now we know that this is exactly 11 plus 3. This is 14. So we're going to green it and put a 4. All right. This is 2 or 3 as well. Oh, interesting. Okay. These two are the same exact digit. Oh, we know this is 4, 6. Right. And we know this is 14. So, okay, easy enough. So this is 2 and 2. I was about to overthink that one. This is a 5, 6. This is 1, 3, 4. Ooh. So what do we... Oh, over here we have 1, 2, 3. We have 4, 5, 6. So this definitely isn't 1. So we're using 2 cells or 3 cells here. Oh, interestingly, the biggest this could be is a 6. Because the biggest this can be is 3, and that automatically makes it add to 6, because it would be using all of 1, 2, 3. So this cannot be a 6. This is 5, this is 6. But now that makes this have to be a 6, making this 3, 1, and 2. And this has to be 5 plus 1, making that 4 and 3, making that 6. Very nice. All right, now I'm guessing we pencil, and then this arrow finishes the job. Okay. So yeah, let's think about that. This is 4, 5, 6, not a 5. This is 3, 4, 5. That's not 3, that's not 5. And this is 1, 2. All right. Now this is an x-sum clue, and this is an x-sum clue. Oh, interesting. Look at where 6 can go in this row. It's here or here. So one of these has to be a 21. If we try to make this one 21, this has to be bigger than 21, which can't happen. So this is the 6. This is a 4. In fact, we could just say 6 couldn't be here right from the start. That's 6. That's 3. All right. Unfortunately, Sudoku doesn't finish this quite yet. This is 21. So I'm going to make it purple to say we're in the 20s and fill a 1 in it. I didn't think I would have to do that, but here we are. So we got to get to 21 somehow. If this is a 4 or a 5, we know the exact value. Let's start with 4. So if this was 4, then it would be 10 plus 5. This would be a 15. So this would be a green with 5. So anyway, 15. To get from 15 to 21, you need to add 6. But we just said that... Oh, okay, wait, maybe that works. So we said this was 4. So this would be 5 and 1. Yeah, that works. And this would be 15. Okay, so that works. So that's probably what it is. I'm hoping 5 breaks in an obvious way. So if this was 5, these would add to 12 plus 5, 17. So to get from 17 to 21, we need 4. And that's not going to happen. Okay, perfect. So this is 4. This is 5. This is 4. This is 5. This is a 15. And so this is 1. This is 2. This is 1. This is 2. Perfect. Very cool puzzle, Palfly. That solved really nicely. It really flowed. Like every time I got like a cool deduction, suddenly it was next to another X sum to think about, which was, this is like, oh, I wonder what I think about next. And then that flowed to the next X sum. Really cool. All right. Very, very cool construction. Palfly expert constructor as always. Let me know how you did. If you enjoyed it, why not leave a like, subscribe, and a kind comment below.